Good morning friends. In the earlier video, I have discussed one example for minimization of DFA using equivalence method. Now for better understanding, I will discuss another example. If you understood the concept, you can pause the video and try to do it yourself. If you have done well, then I will be very happy. If you cannot solve it by your own, please watch the video. Now, how many states are there? We will check it. 1, 2, 3, 4, 5 states are there. First thing you need to check whether it is a DFA or not. If it is not a DFA, how can we minimize it? How we will check whether it is a DFA or not? Q0 on A and B, you have a moves and it is going to Q1 and Q2. Now Q1 on A you have a move, on B you have a move. Q3 on A you have a move, on B you have a move. Come to Q4. Q4 on A you have a move, on B you have a move. Q2 on A and B you have a transition. So this is a DFA. If it is a DFA, then only we will minimize it. If it is not a DFA, we no need to do the minimization. Is it clear? To sometimes people, to make you confused, they will not give a DFA and they will ask you to minimize the DFA. If it is not a DFA, how can you minimize the DFA? Is it clear? Now we will see what is the first step? We need to identify whether any dead states are there or not. What is meant by dead state? From that state, if you cannot able to reach to the final state, that state we will call it as a dead state. From Q0, can I able to reach to the final state? Yes, via Q1, Q3, I can reach to the final state. Is it clear? Or I can reach like this also. If I able to reach in one way, that is enough. From Q0, I can reach to the final state. So Q0 is not a dead state. We will see Q1. Yes, we can able to reach to the Q4 via Q3. So Q4 is a final state. So from Q1 I can able to reach. Now we will see about Q3. Q3 also I can able to reach to the final state. From Q2 also I can able to reach to the Q4. So none of the states are dead states. If there are no dead states, no problem. Okay. Now we will see the next one, whether any unreachable states are there or not. What is meant by unreachable state? From initial state, if you cannot able to reach any state, that state we will call it as a unreachable state. Now see the Q0. From Q0, can you able to reach Q1? Yes. So it is reachable. Q2, you can able to reach. Q3, you may not able to reach directly, but indirectly you can reach via Q1. So Q3 is also reachable. What about Q4? You can reach via Q1, Q3 and then Q4. So Q4 is also able to reach from the initial state. So we can call there is no unreachable states in this one. So if there are no unreachable states, we will no need to eliminate them. So we have done the step 1 and step 2. Now we will go for the equivalence. We will check whether there are equivalent states are there or not. So first we will go for the zeros equivalent. Now what is the zeros equivalent? Will say you have to make it into two sets, consists of non-final states like Q0, Q1, Q2 and then Q3 and final state Q4. So in zeros equivalent, you will make it into two partitions. One is the set of non-final states and set of final states. You have Q4, which is a final state. How you identified it is a final state? As it is having a double circle. Now we will check one equivalent. How I can do the one equivalent method. Now how can I do it? Already we have done the zeros equivalent. We will check there are four friends are there. Q0, Q1, Q2, Q3. There are four friends and one enemy is the Q4. Now we will try to identify, can we separate them or not. If we cannot separate them, it will is very good. If we can separate them, it is good for us. Now we will see. Now Q0 on A, how to do it? We have already discussed. So Q0 on A, where it is going, and Q1 on A. First I will check, can I separate these two persons or not, Q0 and Q1. Now Q0 on A is going to Q1. Q0 on A is going to Q1. Q0 on A is going to Q1. Q1 on A is going to Q1. Now Q1 belongs to only one set. They are going to one. It is in the same set. So we cannot separate as per the alphabet A. Now we will see alphabet B. Q0 on B is going to Q2. Q1 on B is going to Q3. Now Q2, Q3 belongs to same set in the previous equivalent. So we cannot separate them. Q1, Q0 and Q1 cannot able to separate. Now we will see Q1 and Q2 can we separate or not. Q1 on A and Q2 on A, we will check it. Q1 on A is going to Q1. See, if you cannot find directly, you please construct the table and you can do it also. Is it clear? For better understanding, I am telling directly. If you are confusing yourself, you just draw the table. From the table, you can easily identify. Q2 on A is going to Q1. Now, both are going to the same set called Q1. It's not a problem. Q1 belongs to single set. Now Q1 and Q2 according to the B we will see. According to the alphabet B, Q1 on B is going to Q3, Q2 on B is going to Q2. Now these two belongs to single set. So Q1, Q2 also we cannot separate. Now we will see Q2 and Q3 can we separate or not. Right now we have identified Q0, Q1, Q2 are friends. Now we will see Q3 can we separate or not. How we will check Q2, Q3? We will check Q2, Q3 on A, we will check it. Q2 on A is going to Q1. Q3 on A is going to Q1. So with the alphabet A we cannot separate. We will see with the alphabet B. Q2 on B is going to Q2 itself. Q3 on B it is going to Q4. If you see that on B it is going to Q2, it is going to Q4, they are separate. Okay, they are separate states, or we can say that it is going to a non-final state and it is going to a final state. So they are enemies, or we have to separate them. So Q0, Q1, Q2 is still friends and Q3 is enemy and Q4. Now you see it. If Q2 and Q3 are not equivalent and Q0, Q1, Q2 are equivalent, then I will say that Q0, Q1, Q2 are equivalent and it is Q3 is separate. How? If you see that A or Q0, Q1, Q2 are friends. Now Q2, Q3 are friends, then obviously Q3 is an enemy of Q0. Q1 is an enemy of Q3. So if these two are enemies and these three are friends, obviously this and this one is an enemy. Q0 and Q3 obviously will be enemies. Am I right or wrong? So that's why Q0, Q1, Q2 belongs to one set and Q3 belongs to another set, and you have a Q4, already it is a separate set. Now we will see, can we separate these states, or we can have a single state or not. We will check it. See, these friends and enemies I am just telling for an example, don't worry. Okay. Now we will see Q0 on A. Now when you are calculating the two equivalent, you will only check the one equivalent only. Q0 on A, where it is going? Q0 on A is going to Q1. Q0 on A is going to Q2. Now Q1, Q2 belongs to same set, no problem till now. Now Q0 on B, Q1, sorry, this is Q1. Q1 on A, sorry, let me do it again. Q0 and Q1. Q0 on A is going to Q1. Q1 on A is also going to Q1. It belongs to single set, no problem. Let me do it. Q0 and Q1 on alphabet B. Sorry for the inconvenience. Q1 on B is going to Q3. Q0 on B is going to Q2. If you see that Q0 and Q1 is going to different sets from the one equivalent. So what I can do? I can separate Q0 and Q1. Okay, already Q3 is separate and Q4 is separate. Now we will check whether previously Q0, Q1, Q2 are friends. Now Q0 and Q1 are separated. Now Q2 will do friendship with this one or will do friendship with this one. We will check it. How can we do? If we check Q0 and Q2, if they are belongs to same set, so we will say that Q0 and Q1 are single set and Q1 is separated. We will see it. Now Q0 and Q1 are separated. We will check Q2 comes to this set or this set. That is what I want to say. Q0 on A is going to Q1. Q2 Where is Q2? Q2 on A is going to Q1. Still they are going to single set. It is in one's equivalent, it is in single set. Q0 on B. Q2 on B, what is happening? Q0 on B is going to Q2. Q2 on B is going to Q2. Still Q0, Q2 are friends. We will see, we no need to see with the Q1 and Q2 or anyway, just for your confirmation, I will check Q1 and Q2. Q1 on Q2 on A, where it is going? Q1 on A is going to Q1. Q2 on A, Q2 on A is going to Q1. No problem till now. On alphabet B, we will see Q1 on B and Q2 on B, we will see. Q1 on B is going to Q3. Q2 on B is going to Q2. Now, if you see that they belongs to two different sets. Q2 is here, Q3 is here. So, Q1, Q2 are not friends. Q0, Q2 are friends. Or we can say that Q0, Q2 belongs to single set and Q2 is another set. Q1 is another set, Q4 is another set. So, previously you got two sets and then you got three sets. Now you got four sets. Now we will see, can we further reduce it or not? Can we further find the number of more sets or not? Can we further divide this Q0 and Q2 or not? We will see. When we are calculating the three equivalents, we need to check the 2's equivalent only. Now, Q0 on A, where it is going, Q2 on A, where it is going, we will see. Q0 on A is going to Q1. Q2 on A, Q2 is here on A is going to Q1. These two belongs to going to one set, still no problem. Now, Q0 on B, Q2 on B, where it is going? Q0 on B is going to Q2. Q2 on B also going to Q2. Still they are going to same set Q2 itself. Q2 it belongs to single set only. So still they are friends. So if you calculate the three equivalents, it will be looks like this, because Q0, Q2, already Q1, Q3, Q4 are separated. We no need to check them. Now if you see that when we can stop the procedure, if n minus 1 and n equivalent are same, then we can stop. If you see that two equivalents and three equivalents look same, so we can stop the procedure and we start constructing the minimized DFA. That is the step 4 in the algorithm. What is the step 4? Construct the new DFA with the equalized states. So if you see that how many states you will have? Only 4 states. One is Q0, Q2 combinedly. Let me write it as Q0, Q2 combinedly. You will have Q1, you will have Q3, you will have Q4. Now, sorry, I no need to draw, should not draw it. I should draw the circles to represent their cycle. Now Q4 is a final state. Still Q4 is only final state, which is acting as initial state. Previously Q0 is acting in initial state. So Q0, Q2 combinedly will act as an initial state now. So from 5 states we reduce to 4 states. Now we'll complete the DFA procedure. Q0 on A. Okay. Q0 on A is going to where? Q1. Q2 on A is also going to Q1. So Q0, Q2 combinedly on A goes to Q1. Is it clear? Because I need to find Q0, Q2 on A where it is going, on B where it is going, I need to check it. Okay, let me erase this one. On B we will see Q0 on B is going to where? Q0 on B is going to Q2. Q2 on B is also going to Q2. So Q0, Q2 combinedly is going to Q2. So on B we will represent like this. Is it clear? It is going to themselves only. Q0 on B is going to Q2. Q2 on B going to Q2. Where is Q2 is there? It is here. So you will keep it like this. Now if you see that previously Q1 on A is going to Q1 itself. Q1 on B is going to Q3. Q3 on A is going to... Is it visible for you? If it is not visible, I will write it. Or you can write like this. Q3 on A is going to Q1. So this is clear. Q1 on A is going to Q1 itself. Now Q1 is done, Q3 on A is done, Q3 on B it is going to Q4. Now Q4 on A is going to Q1, Q4 on B is going to Q2. So you have to write like this. So this is the minimized DFA for the given DFA. If you see that what are the strings it will accept, it will also accept it. If you want to check, you can check it. Okay. I hope you have understood with these two examples how to minimize the DFA. Okay, and I request everyone to give your comments whether it is a positive feedback or negative feedback. If it is a positive feedback, it will motivate me to teach further. If it is a negative feedback or any suggestions, I will try to improve myself. Okay, and share the videos with your friends. Subscribe to my channel for regular updates. Thank you so much.